In this video, I'm going to go over a little bit of background about what science is in general and what's referred to as applied chemistry, and then I'm going to get into scientific method and the different steps involved with scientific method. So what is science? Science is a very generic term. It's a branch of knowledge built over many years from scientists following a specific method. And if you are following along in the notes packet, the words written in the lighter blue are the things that you would fill in on the notes packet. So there's three main branches of science. There's life science, with the most common example being biology. That's taught in high school. There's physical science, that would be chemistry and physics. And then there's earth science, which would be environmental, which we have in ecology class. That's a semester course that would fall under earth science. There's a bunch of other sciences too. This is just giving the most common ones listed usually. So chemistry, that's what we are going to study. It is the study of matter and its composition, structure, property, and changes. And the reason why people study chemistry is because it is considered a central science, and that is because it overlaps so many other sciences. So with this diagram here, chemistry really has a part to play in a lot of other sciences like biology, medicine, geology. So for geology, you can think about the different rocks that are out there, the different minerals. They all have a different chemical composition. Astronomy, we have an astronomy class at the high school. They might study the composition of the stars, the sun, all that stuff. They have different chemical compositions from planets, for example. Plant sciences, the plants have different molecules associated with them. Environmental science, ecology, pollution, a lot of that involves chemistry. Physics, atomic structure, spectroscopy, materials, biochemistry would have a lot of chemistry. So chemistry really influences a lot of other sciences. So that's why it's considered a central science. Now there's something called pure chemistry, and that's used for research, and that's not really what we're going to focus on a whole lot in this class. This is where people would go in and they spend their entire workday in a lab doing experiments and seeing what will happen and testing results, testing their hypothesis and all that kind of stuff. Applied chemistry is more what we are going to work on, and that's used in ordinary people's lives. And this is the part that a lot of people a lot of times think is a little more interesting, unless they're like the diehard scientists in a lab all the time. So if you think about just in a house, a building itself, there's a lot of chemistry that goes into a lot of those different parts. The wires and cables, they're going to carry electrical information, what they're made out of, the different types of sheathing that might go around them, the different types of cables, how big they are, whether it's an Ethernet cable or it's an electrical cable or whatever the case is. Paint, believe it or not, has a lot of chemistry that goes along with it. It has a lot of different things associated with it, like titanium dioxide. There's things like binders and pigments that give you the different colors. There's all sorts of different stuff that goes in there, a lot more than you probably realize. Insulation, the stuff that keeps your house from getting too warm or too cold. They could be made from a lot of different materials. There's different R values for how effective they are. Again, a lot of research goes into making those. Plastic piping. People used copper a lot more in the past. Now it's going towards plastic, so they have to make the plastic so it can withstand different temperatures and different pressures. So again, a lot of research there. Plastic flooring, something that's going to last a long time, maybe not get scratched. Maybe provide a little bit of water resistance. Household appliances, all the different electronics going on in there is going to involve different chemicals in their parts. Plastic fencing, so for example, something that is not going to shatter easily when it's really cold or not get deformed when it's really hot, right? So they have to design it in a way that's going to be able to withstand big temperature changes. Same thing with vinyl siding. You're going to want something that's going to last a really long time on your house. You don't want to have to replace the vinyl siding every couple years. Window molding, a lot of times was wood in the past. Now they're doing things made out of MDF, maybe medium density fiberboard or other stuff. Things that they're trying to use, again, that will last longer, maybe cost less money, or maybe have mildew resistance. Window adhesives, you don't want your windows leaking when it rains, right? So the different types of caulks, silicone caulks, there's all sorts of stuff. Plywood, there's different grades of plywood. They have some that is used as a fire barrier, basically. So if you have a row home or something like that, You might have to use fire-rated plywood between the houses. Basically, if there's a fire, it will help slow the spread of the fire. So, in a house, there's a lot of different chemistry that's going on with that. And a lot of that would be considered applied chemistry. So whenever science classes are starting, a lot of times people start off with the scientific method. And this isn't going to be any exception. And this is probably stuff that you heard of before, so I'm not going to spend a long time talking about it. The scientific method is a series of steps used to find a solution to a problem. And my guess is you can probably think of a lot of the steps at this point. There's going to be 6 total. There's observe and consider a problem. So it always starts off with some sort of problem that you're trying to figure out. You're going to form a hypothesis. A lot of times people simplify that by saying it's an idea that you could test. You're going to design an experiment. You're going to do the experiment. You're going to collect and analyze the data. And then hopefully you can come up with a conclusion. And the conclusion might be that your data supports your hypothesis, which is good. A lot of times that's not the case right away when someone's trying to figure out a problem. A lot of times they have to do an experiment and the data does not support the hypothesis. So they have to rethink the hypothesis or change the experiment, maybe a variable or something like that. And then you're going to summarize the results. So in everyday life, an example. So say you're at home baking cookies and you baked your first batch and it's like, all right, my cookies are burnt. So why is that? Well, what you could do is, first thing is form a hypothesis. And for something like that, it should be pretty straightforward. The first thing you might think of is, well, maybe my oven's at too high of a temperature. I have it set at 400 degrees Fahrenheit. Well, you can design an experiment real quick. Lower the temperature down to 350 degrees Celsius. Cook your cookies, see if they burn. You might want to change the time too. Usually what happens from a science point of view is you would only change one variable at a time. Now, overall, this sounds like a pretty fun experiment to do because at that point, to collect the data, you're really just eating cookies. But that would be an example of scientific method in everyday life. Why did my cookies burn? Well, I could try lowering the temperature of the oven from 400 down to 350 or whatever the case is, collect the data, and if they're not burned at that point, then you're good. All right, so something like that. Applied chemistry. All right, now experimental design. When you are designing an experiment, there's different observations you have to make, and observations are just things you experience either from your senses or aided with technology. So through your senses, if there's a color change, a change in smell, a loud sound, a gas is formed, they would be things through your senses. Now, aided by technology, maybe that is using electronic balance, is something that we would do in class a lot. And there's a ton of examples of aided by technology, but that's probably the most common one. Did the mass change according to my balance? All right, now there's 2 different types of observations. There's qualitative, and think about the word like quality, the root of that word. It's descriptive. It's talking about things like color, size, shape, things you could just observe with your senses. Quantitative, think about the root of that word, quantity. That means it can be measured. So quantitative data is always going to have some kind of number, and we want you to get in the habit of including a unit. So maybe the temperature went up by 10 degrees Celsius, or the mass decreased by 5 grams. All right, it's always a number and a unit. So the degrees Celsius and the grams would be the units. So quantitative involves a number, qualitative does not. It's just descriptive in nature. Now that hypothesis, another way you can think about that is a testable statement. Experiment tests a hypothesis, and natural law describes how nature behaves. All right, so how being a key word there, how nature behaves, and theory explains why nature behaves the way it does. So sometimes people say natural law, sometimes they say scientific law. I'm fine with either one of those. So an example of a difference between natural law and theory. Imagine you're outside and you're just laying under an apple tree relaxing, and you notice that an apple falls from the tree to the ground. Well, natural law would just be that when an object is dropped, it's going to fall downwards. Now, theory would be explaining why that happens, and that's where the idea of gravity comes in, right? So natural law is if you're sitting under that tree and an apple falls off the tree, it's going to fall downwards. Theory explains why that happened. Gravity caused it to do that. Right? So that's the difference between natural law and theory. Sometimes people get those confused. Right, so that's the general setup for today for the scientific method. And now we are going to end up doing some practice with scientific method.